Today we're going to continue I have isolate variable x and get an answer. So we're going to, for inverse trigonometry, use the inverse trigonometric functions to find the measure for the angle. I'm asked to solve for x. Typically, I would find sine of some angle measure, and it would equal some ratio. Well, here we don't know what x is. So if I have sine of x equals, I'm going to give myself what I'm going to do to the sine function is I'm going to apply the inverse sine function. So I'm going to apply to both sides because what you do to one side, you do to the other. I'm going to apply to both sides sine inverse. Sine inverse. Now, this inverse trigonometric function for sine, it can be said several different ways, or written several different ways. So when you write it, it can look like this. It can also look like this. We can say sine inverse. And we can also say inverse sine. So these are all acceptable ways to label or say the inverse sine function. So what happens when you perform an inverse of something? Well, they undo each other, kind of like multiplying and dividing undo each other's operations. Squaring and square rooting undo each other's operations. Applying the inverse sine to the sine function undoes the sine function. So what you're left with is x. X equals sine inverse of 2/3. Now, this is the exact answer. And a lot of times I'm asked to find the exact answer. So I'm going to box this because this is the exact answer. But occasionally I will ask you to find the answer rounded to the nearest thousandth. The nearest thousandths place is tenths, hundredths, thousandths. This one right here. So 3 decimal places, that's the nearest thousandths place. So what I'm going to do is make sure that you understand that we should be able to round this to the nearest thousandths place. So x will equal some kind of amount of degrees. So I'm going to pull up Desmos, and in Desmos, I want to make sure that I'm measuring in degrees and not radians. So I go to my settings wrench. I click degrees to make sure I'm measuring in the correct units. Otherwise, I may get some negative answers. And what I want is I want to evaluate and the 3 enough to round the 0 up. And this is measured in degrees because remember, I'm finding an amount of degrees. I'm finding an angle measure. So 41 point. The gist of this first problem is to help you to understand that there are inverse trigonometric functions that exist, and they can undo your sine, cosine, and tangent functions. whenever you need to evaluate the angle measure. So here, if sine of angle A is equal to x, then the measure of angle A equals to the of x. So you can kind of motion to the other side only doing sine inverse. If cosine of angle A equals y, then the measure of angle A will equal cosine inverse of y. If tangent of angle A equals z, then the measure of angle A will equal tangent inverse of z. So these are just kind of some quick references for you to use throughout. Since degrees equals 1/2, and we saw that in our last set of notes, then we can also say that sine inverse of 1/2 is equal to 30 degrees. So we can kind of switch the way that we write these, and it gives us angle measures instead of ratios for side lengths. So what I'd like to do next is take a moment to calculate angle measures from trigonometric ratios. We're going to use Desmos, which should already be in degree mode and not measured in radians, to find each angle measure, and make sure that your calculator is in degree mode, but make sure that you're also rounding to the nearest thousandths place. So I'm going to do the first one for you, and then I'm going to let you do the other two and you can check. So the first one that I want to find is the tangent inverse of 0.75. So I'm going to go to my functions. I'm going to find tangent inverse of 0.75, and I get 36.8698, but that's going to round to 36.870. So remember that we are estimating, we're rounding, so we don't have the equal sign, we have the about equals to, so the estimation sign. We're going to do the same thing on part B and on part Z. So pause your video and try to calculate and estimate these inverse cosine problems. (134 degrees). Make sure you label in degrees. And 0.7 is roughly 4. So now, if we've practiced a little bit with the Desmos and the calculator, I'd like to move on to the next problem, which is solving right triangles. It asks you to find the unknown measures, so all unknown measures, round answers to the nearest thousandth if they cannot be expressed as exact answers. Now this is important because it says to round answers to the nearest thousandth if they cannot be expressed as exact answers. So that means first try to express them as exact answers, and if you can't, then round them. So if you just round all of your answers, well, that's not necessarily what I'm asking for. I only want rounded answers if I can't have exact answers. So strive for the exact answers here. So let's look at your triangle. Your triangle is a right triangle. I have no idea what the measure of angle A and C are, so I'm going to have to find those. Measure of angle A equals measure of angle C equals, and then I also don't know one of my side lengths. I know that side length AB has a measurement of 12 units, side BC has a measurement of 10 units, and then side AC is this unknown side length. And so I'm also going to need the length from A to C. So these are the three things that I'm finding in this problem. So let's start out by trying to find maybe the measure of angle A. So I'm going to use one color for each piece. For the measure of angle A, I'll use black pen. So I'm going to mark my angle A, make sure I know which angle I'm talking about. I need to label my triangle, so the hypotenuse will always be the long side across from the right angle. My opposite side, opposite of angle A, is over here, so here's the opposite side. And that leaves 12 to be measuring the adjacent side. I also, since I don't know what this length is, I'm going to give it a variable x. And I've already marked this angle as an unknown angle, so I'm going to leave that the way that it is. So I need to figure out one of my pieces. Well, if I'm looking for the measure of angle A, I better use a trigonometric ratio that uses the two side lengths that I already have. Well, if you have trouble remembering your trigonometric ratios, I'm going to write SO, CA, TOA to help you remember. If I'm finding the measure of angle A, that means that I need to use the two sides that have measurements. That would be the opposite and the adjacent. So if I go look at the trigonometric ratios that use opposite and adjacent, because that I don't know. So now I need to apply so that I can solve for the measure of angle A. So tangent function to both sides. That means that let's simplify this and call it, instead of 10 over 12, let's call it 5 over 6. And I'm measuring in degrees. Now, do I need to put this in the calculator and find a decimal approximation? No. It asks me to round my answers only if they cannot be expressed as exact answers, and it might not be nice and pretty, but it's not rounded, and it gives me the exact answer if I type it into a calculator or Desmos. So I found the measure of angle A. And give that here. Remembering that I'm measuring in degrees, so put your units in there. Now I need to find angle C. So I'm going to change my colors for that. I notice that these two are not the same length, so I don't have congruent angles here, so I marked this one as 2 arc marks instead of 1. So I still have a hypotenuse here, but now this side over here is the opposite side, and this side here is the adjacent side. So again, I want to use a trigonometric ratio that will allow me to find the measure of angle C. That means that I need to know the two sides that go into the trig ratio. So again, I'm going to need to use the 10 and the 12, the adjacent and the opposite. And again, I will be using the tangent function because it's the trigonometric ratio that uses the opposite and the adjacent sides. So I'm going to be finding the tangent of angle C, and it's equal to the opposite side, which is now 12, over the adjacent side, which is now 10. I don't want the tangent of angle C, I want the measure of angle C, so I'm going to apply my inverse trig ratio to both sides. So now my inverse tangent and tangent will cancel out. I'm left out with just the measure of angle C equals tangent inverse of, let's simplify this to 6 over 5, and I'm measuring in degrees. So again, exact answer, no rounding necessary. Found the measure of my angle. So now the last piece of information needed, because I needed to find all of the unknown measures, is the side length AC. So think of a way to allow me to find the missing side length of a right triangle if I know the other two. your mind. Right. So perhaps if I want to solve for x, the square root of 244, which is going to simplify. So I can to square root of 4, square root of, let's see, 4 and 24 6 times, 4 1 time. There we go. That works out nicely. And so that equals the square root of 4, which is 2, and the square root of 61, which can't be broken down anymore. So this is my exact answer. So AC is equal to 2 squared 1. There are no units on the other two sides of the triangle, so I'm going to leave it the way that it is. Okay, so let's move on to the last page. Again, we are asked to find the unknown measures, all of them. Round answers to the nearest thousand only if they cannot be expressed as exact answers. So let's look at a problem. We have a right triangle with two sides that have measures. C does not. That's going to be a part that we're going to have to find. I also don't know the measure of angle B and the measure of angle C. So I'm going to have to find those as well. Those are all of the unknown measures. So you can really do these in any order that you want. A lot of people choose to use the Pythagorean theorem first and find the missing side length, and that's totally fine. However, I'm going to start with finding the measure of angle B. So if I'm finding the measure of angle B, I need to label. CB is always going to be the hypotenuse. The opposite side over here is side AC, and then this would be the adjacent. I don't know which trig ratio to use, so I'm going to remind myself which sides are used for each ratio. So SOHCA, TOA. I have this unknown angle measure right here, so I need to make sure to use the sides that I have in the picture. So I have the adjacent side and the hypotenuse that are given to me. So the adjacent side and the hypotenuse are being used here, so I should be using cosine of angle B. So cosine of angle B is equal to the adjacent side over the hypotenuse. The adjacent side is 12 square roots of 2. The hypotenuse is 20. I don't want the cosine of angle B. I want the measure of angle B. So I'm going to apply the inverse cosine function to both sides. Let's find the measure. Hypotenuse. Now this side is the opposite side, and this side is the adjacent side. Here, if I'm measure of angle C, I need to use the two sides of 4 and the hypotenuse. Here, here, one uses the opposite and the hypotenuse. That would be the sine function. I'm going to use the sine function to find the measure of angle C. The sine function of C is equal to the hypotenuse. So that would be 12 square root of 2 over 20. I'm going to apply the inverse sine function to find that the measure of angle C is equal to inverse sine of. If I simplify this, I end up with 3 square roots of 2 over 20. And I'm measuring in degrees. Oh, and I do notice that I put a 6 and a, oh, good grief, let's see. Let's figure out where all of these errors happen, because I see a bunch of errors with my simplifying. So 12 and 20 simplifies to 6 and 10, simplifies to 3 and 5, so this should be a 3. This should be a 5. And then here, 12 over 20 should simplify to 3 over 5. So this should be a 5 as well. So please pardon my simplifying. It's not going very well today. Okay. Now, last thing we have to find is the side length AC. So if I have 2 side lengths and a missing side length, well, I'm going to use the Pythagorean theorem to go ahead and calculate that. So I have a squared plus b squared equals c squared. One of the legs is x. The other leg is 12 square roots of 2. And then the hypotenuse is 20. So I have x squared plus 12 squared is 144, square root of 2 squared is 2, and 144 times 2 is 288. 20 squared is 400. If I subtract 288 from 400, I get x squared equals, what is that, 112? And if I square root both sides, I get x equals, if I break this up, let's break it up this way. So 2 times 56 and 2 times 28 and 4 times 7. Okay, there we go. So x equals, here's a pair, here's a perfect square, and then out here we have a 7, so that's going to be a leftover, and this equals 4 square roots of 7 if you simplify. So my length from A to C is 4 square roots of 7. Okay. Last question today has no diagram, which means it's going to be really helpful if you could draw a diagram. It says a soccer goal is 8 feet tall. You kick a ball from 10 feet away that hits the crossbar at the top of the goal. At what angle was the ball kicked? So at what angle was the ball kicked? So let's make sure that we have all the components right. We're playing soccer. We've got a soccer goal. And maybe it comes out like this. And maybe we've got all these pieces. There we go. And then we've got you over here. And you kick the ball. And the ball's right here. And it sails up and it's going to hit right here at the top. So all the way from your foot, all the way to the top. Now we've got this triangle that's created that comes down and out. And it's a right angle right here. So here is our triangle. And the soccer goal is 8 feet tall. So I'm going to put an 8 right here. And you kicked the ball from 10 feet away. So the distance from you to the goal is 10 feet. And you're asked to find at what angle the ball was kicked. So I'm not asked for this angle. I'm not asked for this angle. The kicking is happening right here, so this is the angle that we don't know. So we're going to call this x degrees. So we have 2 side lengths and a missing angle measure. So let's see what we can label, and let's see what trigonometric ratio we can use. Remembering that TOA will help us decide our ratio. So this is obviously the hypotenuse. This side over here, the 8, that's the opposite side. This side down here, that's the adjacent side. So the 2 sides that we have measures for, the 8 and the 10, would be the opposite and the adjacent. So if I go look at where the opposite and the adjacent show up in trigonometric ratios, the one that uses them both is the tangent. So we're going to find the tangent of angle x, and it's equal to the opposite side, which is 8 feet, over the adjacent side, which is 10 feet. I could simplify this, and I could say the tangent of angle x is, if I divide both of those by 2, I get 4/5. I want to apply the inverse tangent ratio to both sides, so I'll get that the measure of angle x equals tangent inverse of 4.5 degrees. And so I can answer my question. At what angle was the ball kicked? Well, the ball was kicked at an angle of inverse tangent 4/5 degrees, or about, so here we are going to give kind of a rounded answer. So or about, let's pull up our calculator. If I go find the inverse tangent function, and I take it of the fraction 4/5, I get about 38.6, not 59, but 60, so 660 degrees. So today we were able to use the inverse trig functions to find missing angle measures in our right triangles.